In section 7.3, we'll be focusing on formulas involving polygons. It's extremely important that you memorize the names of the various polygons, that you memorize the formulas, and then you also read all of the questions and problems very carefully to determine which formula you should use. Let's first start off by taking a look at what n represents. N always represents the number of sides of the polygon. So below, we see a table in which we have various sided polygons. For example, a three-sided polygon we know is a triangle. I'd like you to take this time to fill in the rest of the table on your own. Hit pause and then hit play once you're ready to compare your answers with mine. It is extremely important that you have all of these names memorized. And also, notice for the 11-sided figure, we do not have a specific name that I require you to memorize, so you can just call that shape an 11-gon. Same goes for a 13-sided figure or a 14-sided figure, etc., etc. All right, let's take a look at this first formula. If I asked you to find the sum of the interior angles, I'm asking you to find what all of the angles add up to, those interior ones. The formula that we have to use to find that is n minus 2 times 180. But let's talk about where that formula stems from. To explain the formula, I'm going to use a hexagon. So our n is 6. It's a hexagon. Let's talk about where the n minus 2 comes from. So if we start at one vertex of that shape, and we draw in the diagonals from that vertex, let's see what we have formed. Do you notice now we have some triangles that have formed? Can you please do me a favor and count how many triangles we have? The answer is 4, which means that that's where our n minus 2 comes from. If we were to do this in any shape, okay, we would always have 2 less. Okay, the number of triangles formed would be 2 less than the number of sides. And we multiply it by 180 because of the sum of the angles of a triangle add up to 180, and we have 4 triangles there. For the sum of the exterior angles of any shape, it's 360 degrees. That's your answer for every single shape, regardless of how many sides the figure has. So your answer is 360 degrees for the sum of the exterior angles. Let's talk about why the sum of the measures of the exterior angles of any polygon is 360 degrees. We are going to analyze a pentagon and a triangle for this. I labeled the exterior angles with numbers, as you can see, and now let's walk around the figure and determine some relationships. We know that this exterior angle 1 plus the red interior angle must add up to 180 degrees. Any interior and exterior angle are supplementary in a polygon. We know that angle 2 and the yellow angle must add up to 180 degrees. And we could keep going, but instead of doing that, we know that we have 5 sets of supplementary angles, 5 sets of interior and exterior angles, in which each one will add up to 180 degrees. So we can multiply 180 by 5 to get 900 degrees. That would give us the total sums of the interior and exterior angles combined. But we know how to find the sum of the interior angles using the formula that we just talked about, which is n minus 2 times 180. So we know that all the interior angles of this pentagon add up to 540 degrees. We could subtract that from the 900 degrees, which we found below, to find that the sum of the exterior angles of this pentagon is 360 degrees. Let's compare it to the triangle. For the triangle, once again, I'm labeling the exterior angles 1, 2, and 3. And just like we talked about before, we know that this exterior angle 1 plus the red angle must equal 180 degrees, and we can continue that all the way around the triangle. Let's multiply 180 by 3 since we have 3 sets of interior and exterior angles. So we know that that gives us 540 degrees for both the interior and exterior angles sum. But in any triangle, we know the interior angles of a triangle add up to 180 degrees. Subtracting that from 540 degrees, it leaves us with 360 degrees. If we do this for any other shape, it will always work out the same way. And then finally, the third formula that you have to know is how to find the number of diagonals that can be drawn in a shape. And that's n times n minus 3 divided by 2. I'm going to use a hexagon to demonstrate where this formula comes from. So from one vertex, n, from each vertex n, we can draw n minus 3 diagonals. Okay, so let's think about that. So we have 6 vertices total. And from each vertex, we could draw 6 minus 3, or 3 diagonals, as you can see here. Now let's go over here and draw some diagonals from this vertex, for instance. Okay, so that's another vertex. So we can draw, once again, n minus 3 diagonals from that vertex. So we could draw 3 diagonals from that vertex, and we have 6 vertices total. Do you notice how, from the first drawing and the second one, we overlapped at that diagonal? We can't count that diagonal twice. So that's where the divided by 2 comes from in the formula. So from each vertex n, we can draw n minus 3 diagonals, but we have to divide by 2 as to not double count some of those diagonals. For parts A and B, we want to find 3 things for each problem. We want to find the sum of the interior angles, the sum of the exterior angles, and the number of diagonals. I am going to try to encourage you to try this out without looking back at the formulas, okay? And obviously they're right above you if you forgot them, but you do have to have these memorized. And also try to remember the names of the shapes too, just to kind of test yourself. All right, so the first formula we use to find the sum of the interior angles is n minus 2 times 180, and we're just substituting in 6 for n since we have 6 sides to this figure. So our answer is 720 degrees. For number 2, we want to find the sum of the exterior angles. Well, we don't even have to do any work for that one. Our answer is 360 degrees because that's how it is for every shape for the sum of the exterior angles. And for number 3, we want to find the number of diagonals. So we use the formula n times n minus 3 divided by 2. Once again, we have 6 sides, so we're going to do 6 times the quantity of 6 minus 3 divided by 2. So from each of the 6 vertices, we could draw 3 diagonals, but we have to divide by 2 as to not double count those diagonals. So we get 9. Part B, let's go ahead and fill this in. We have 5 sides there. We counted that. It's a pentagon. So we're using 5 for n. So when we do our n minus 2 times 180, we get 540 degrees for the sum of the interior angles. For number 2, the sum of the exterior angles is 360 degrees, like always. And then for number 3, when we do our n times n minus 3 divided by 2, we end up getting 5 for the answer. What I'd like you to do for parts C and D is I'd like you to try these on your own, work them out, and then once you're done, hit play again. So you're going to pause the video and then you're going to hit play again to compare your answers with mine and double check your work. Alright, so for this, number 1 for part C, for the sum of the interior angles, you should have gotten 2,340 degrees. For part 2, you should have gotten 360 degrees. And for part 3, the number of diagonals, 90. And then for D, you should have gotten for part 1, 1,080 degrees, for part 2, 360 degrees, and for part 3, 20 diagonals. Please keep in mind for the word problems, they may be jumbled up in the future, so you want to make sure you read them carefully.